SpaceX has a license to send Starship to orbit on Flight 13, not a plan, not a projection, an actual license approved by the FCC. So why are they almost certainly not going to use it? This isn't a story about a failed engine. It's not about a booster landing 300 kilometers off target. I covered both of those in the 2 previous videos in this series. Today is about the story most people are reading backwards. When SpaceX chose to repeat Flight 12's profile instead of pushing to orbit, most of the community called it a step back. I don't see it that way, and I'm going to show you, with real data, why this might be the smartest decision SpaceX could have made right now. Let's get into it. Let's start with that license. In April 2026, SpaceX filed with the FCC, the Federal Communications Commission, for authorization to fly Flight 13. In that filing, the second stage, Ship 40, is classified as orbital, not suborbital like every previous flight. Orbital. When that hit the internet, the space community exploded. SpaceX is about to put Starship in orbit. Flight 13 is going to make history. But most people missed one critical detail. An FCC filing is not a flight plan. It's a maximum authorization. When SpaceX files with the FCC, they don't submit a detailed flight plan. They apply for what's called a Special Temporary Authority, an STA. The STA defines what they're permitted to do within a given window. It's a ceiling, not a floor. Translation: SpaceX is allowed to send Ship 40 to orbit. That doesn't mean they will. Why file orbital if they're not sure they'll go orbital? Flexibility. If you file suborbital and the flight runs better than expected, you can't just push to orbit. You don't have authorization. But if you file orbital and the in-flight data isn't strong enough, you can stop at suborbital. No violation, no problem. That's why SpaceX always files the broadest authorization possible. Not because they're committing to everything in it, because they want to keep every option open. The data is clear on this. Flight 10 filed orbital. Outcome, suborbital. Flight 11 filed orbital. Outcome, suborbital. Both times SpaceX made the call based on data, not on the license. So the real question isn't, does SpaceX have permission to go orbital? The real question is, does data from Flight 12 give SpaceX enough confidence to push to orbit on Flight 13? To answer that, we need to look at what Flight 12 actually left behind. Failure mode number 1. Same incident. 2 completely different outcomes. If you watched the previous video in this series on the Block 3 redundancy architecture, you already know this. Ship 39 lost a Raptor vacuum engine mid-flight. The flight computer compensated. The vehicle still hit the target in the Indian Ocean. That's fault tolerance working as designed. But today's question is different. What if that same failure mode happened not on a suborbital trajectory, but on an orbital one? The answer changes completely. Scenario 1. Engine failure on a suborbital trajectory. Ship 39 during Flight 12 is the clearest example. Engine shuts down. Trajectory deviates. The flight computer compensates by extending the burn across the remaining 5 engines. The vehicle burns through nearly all of its propellant reserves. But in the end, it hits the mark in the Indian Ocean. SpaceX gains a valuable data point. The program moves forward, not ideal, but completely manageable. Scenario 2. Engine failure on an orbital trajectory. Ship 40 is in low Earth orbit, LEO. Altitude approximately 200 to 300 kilometers. Velocity approximately 28,000 kilometers per hour. Engine shuts down. The flight computer attempts to compensate, but propellant is nearly depleted after correcting the ascent. Not enough left to execute a deorbit burn. Ship 40 can't come home. Now you have an object weighing over 1,000 metric tons in an uncontrolled orbit around Earth. Uncontrollable. Unrecoverable. This is no longer a single flight engineering problem. The FAA won't just open a standard mishap investigation. NASA, SpaceX's HLS partner for Artemis, will have to reassess Starship's reliability across the board before the contract can move forward. And SpaceX's IPO will face questions from investors that won't have easy answers. Same failure mode, engine out. Completely different risk profile depending on context. Suborbital. Failure is a data point. Painful but recoverable. Orbital. With an unresolved root cause, failure can become a program-level crisis. Unrecoverable. SpaceX isn't afraid of engine failures. They're afraid of an engine failure in the wrong context, where the consequences can't be undone. Per SpaceX and FAA statements, following Flight 12, the Raptor vacuum engine failure on Ship 39 was not identified as the driving factor in the official mishap investigation. The investigation focused on the booster side. That doesn't mean SpaceX ignored the ship-side engine failure. It means the FAA didn't require SpaceX to resolve it before flying again, from a regulatory standpoint. But SpaceX still needs to understand why it happened, because if they don't understand it, and they push to orbit and it happens again, no one gets to say we didn't know. Why boost-back failure is a predictability problem, not just a reliability problem. Per SpaceX's official post-flight statement on Flight 12, Booster 19 completed the directional flip after stage separation, exactly as planned. But when it attempted to ignite engines for the boost-back burn, it couldn't light enough of them. Result: partial boost-back burn, early termination. Booster 19 came down in the Gulf of America, approximately 300 kilometers off the intended target. The previous video explained why that made a catch attempt impossible. Today's deeper question is, why is boost-back failure harder to fix than most people think? The answer is the difference between two concepts: reliability and predictability. Reliability is whether a system works correctly. Predictability is whether you know in advance that it will work correctly, under specific conditions. You can have reliability without predictability. Think of an old car that sometimes starts and sometimes doesn't. When it starts, it runs perfectly. Good reliability. But you never know which mornings it'll fire up. Poor predictability. A catch attempt doesn't just need a reliable booster, it needs a predictable one. For the Mechazilla arms on the launch tower to catch the booster, that booster has to arrive at a precise point in space, accurate to within meters. Not tens of meters. Meters. The entire boost-back burn and landing burn sequence has to execute exactly as calculated. Not just in the right direction, the right thrust, the right duration, the right angle. If boost-back fails in an unpredictable way, the booster could come down hundreds of kilometers from target, or less, or more. You don't know. And when you don't know where it's going to land, you can't position the Mechazilla arms. Because if the booster doesn't return to the right point and the arms are already extended, you've placed the entire launch tower, the entire ground infrastructure worth hundreds of millions of dollars in potential danger. No responsible engineer makes that call. So what does SpaceX need before a Block 3 catch attempt is even on the table? At minimum, one flight, just one, where a Block 3 booster successfully executes a full boost-back burn under real flight conditions, with Raptor 3 engines, at the higher separation velocity of Block 3, under the full post-separation dynamics of an actual mission, not in simulation, in actual flight. That's why Booster 20 in Flight 13 isn't flying to get caught. It's flying to prove that Block 3's boost-back burn can work correctly and predictably. If Booster 20 delivers that, it will be a more important milestone than any catch attempt, because it lays the foundation for every catch attempt that follows. Ground test data from McGregor following Flight 12 shows SpaceX running aggressive Raptor 3 testing, but real confirmation only comes in flight. If this level of analysis is useful to you, going deep instead of just reporting headlines, a like and subscribe genuinely helps content like this reach more people. Why repeating the profile is the fastest path to orbit. When SpaceX announced Flight 13 would repeat Flight 12's suborbital profile, the most common reaction in the community was frustration. Suborbital again? When do we actually go to orbit? SpaceX is slowing down. That reaction is understandable, but it's measuring progress with the wrong metric. You have two unresolved failure modes, one on the ship side, one on the booster side. Both involve Raptor 3, a completely new engine that had never flown before Flight 12. In that context, you have two options. Option 1, push to orbital trajectory on Flight 13. Add the deorbit burn, add orbital operations, add complexity. If something goes wrong on an orbital trajectory, you now have 3, 4, 5 unvalidated variables in play simultaneously. Investigation gets dramatically more complex. Recovery timeline stretches longer, and potential consequences are incomparably more severe than anything suborbital. Option 2. Repeat the suborbital profile in a known environment. Validate SpaceX's fix for the boost-back burn. Validate Raptor 3 engine stability. Collect more Block 3 data before layering in orbital complexity. If Flight 13 suborbital succeeds, boost-back burn works, engines hold stable, you now have a genuinely solid foundation to design Flight 14 with an orbital trajectory and a catch attempt. Intuitively, Option 1 looks faster, one step, but in the reality of a test campaign, Option 2 is usually significantly faster. Because Option 1, if something goes wrong, creates an investigation that drags on for months, with ambiguity about root cause that you can't resolve cleanly. Ambiguity is the single biggest enemy of program velocity. Option 2, if it succeeds, creates a clean foundation. No ambiguity, no open questions hanging in the air. The next flight is designed with real confidence. This is what engineers call going slow to go fast. SpaceX's own history confirms the pattern. Look at Falcon 9, CRS-7 in 2015, a strut failure in the helium pressure vessel. Amos 6 in 2016, failure during a static fire. After each one, it wasn't just the schedule that suffered. Reputation took a hit. Recovery took months. Then SpaceX became more systematic, more testing before pushing new milestones. And from 2018 onward, Falcon 9 built one of the most remarkable track records in launch history, over 300 consecutive flights without a major failure. That patience is what produced reliability, not urgency. 3 clocks running in parallel. The Flight 13 decision isn't just about one flight. It affects at least 3 much larger things running simultaneously. Clock 1, Artemis. NASA, Artemis 3, the mission to return humans to the moon for the first time in over 50 years, is targeting 2028, and Starship is the human landing system, the HLS, for that mission. But before Starship can land astronauts on the lunar surface, SpaceX needs to demonstrate orbital propellant transfer, on-orbit refueling. Because Starship, when it reaches LEO, doesn't carry enough propellant to travel directly to the moon, it needs to be refueled in orbit by a tanker Starship before continuing the mission. That is one of the most technically complex operations humanity has ever attempted at this scale, and it requires Starship to be reliably operational on orbital trajectories before NASA will permit the demonstration. Every time Starship encounters an unresolved failure mode on orbit, the Artemis timeline gets impacted, not because NASA wants to be an obstacle, because NASA is responsible for crew lives. Clock 2, Starlink 5-3. SpaceX has announced Starlink 5-3. Satellite deployment will begin in the second half of 2026. A single Starship can carry 60 Starlink 5-3 satellites per flight. Compare that to 24 Starlink 5-2 satellites on a Falcon 9. That's a massive difference in deployment economics and cadence. But to deploy Starlink 5-3 on Starship, Starship has to reach orbit reliably. Every orbital failure is a delay, not just for the test campaign, but for the entire commercial deployment strategy. Clock 3, the IPO. SpaceX has filed for an IPO, and in that S1, SpaceX is explicit. Their growth strategy depends on the ability to scale launch cadence and payload capacity, which depends on Starship's successful development at scale. Investors will read every Starship flight as a signal about where the company is headed. A Starship stuck in uncontrolled orbit right before an IPO is a headline no one at SpaceX wants to explain to Wall Street. When you look at all 3 clocks together, the decision to repeat the suborbital profile stops looking like a step back. It's the only move that keeps all 3 clocks running in the right direction. Booster 20, the real main character of Flight 13. Booster 20 is the most important element of Flight 13. not Ship 40. Current data shows Booster 20 is in the cryo-testing phase at Massey's, SpaceX's test site at Starbase. That's the first step in the qualification chain. After cryo-testing, static fire at Pad 2, then wet dress rehearsal, then stacking with Ship 40, and there's a detail most coverage has skipped. During Flight 12 prep, SpaceX transferred at least 10 Raptor engines from Booster 20 to Booster 19. After Booster 19's 10-engine static fire was aborted. That means Booster 20 is currently in the process of getting its full engine complement reintegrated. Using recent Block 2 booster timelines as reference, the window from cryo-testing to a successful static fire runs approximately 3 to 4 months. Block 3 with Raptor 3 could take longer, because every issue discovered during testing is being seen for the first time with this configuration. Additionally, the FAA mishap investigation from Flight 12 needs to be cleared before any launch can proceed. Per NSF, NASA spaceflight, Flight 13 could occur in the July to August 2026 window. That's based on a reasonably optimistic timeline. If any technical issues emerge during Booster 20's test campaign, that window could shift to Q3 or Q4. 3 things to watch in Flight 13. Here's the specific lens to use when Flight 13 happens. So you're not just watching the live stream waiting to see, did they catch it? Did it blow up? Watch point 1, the boost back burn. This is the single most important KPI for Flight 13. If Booster 20 executes a successful boost back burn, full burn, on spec, no early abort, that confirms SpaceX understood and fixed Booster 19's failure mode. It's the foundation for catch attempts, for reusability, for rapid launch cadence. If Booster 20 has boost back trouble again, a catch attempt with Booster 21 gets pushed out at least one more flight. Watch point 2, Raptor 3 engine stability on the ship. Ship 40 will be only the second time Raptor 3 engines have flown on an upper stage. If there's no engine failure during ascent, that's a significant data point indicating Ship 39's failure was an isolated incident, not a systemic flaw in the Raptor 3 design. The conversation about orbital trajectory opens up seriously for Flight 14. If there's another engine failure, the investigation goes deeper, and orbital trajectory stays on hold. Watch point 3, whether SpaceX includes an in-space relight test. On Flight 12, that test was skipped. The trajectory had already deviated following the engine failure. If Flight 13 includes an in-space engine relight in the flight plan, and it succeeds, that's a direct milestone toward deorbit capability, a prerequisite for orbit. If Flight 13 doesn't include a relight test, that confirms SpaceX is still in a conservative phase, validating the fundamentals before adding new complexity. Those 3 data points will tell you far more about where the Starship program actually stands than any catch attempt or explosion clip. And there's one more thing. Something related to Ship 40 that SpaceX hasn't talked much about publicly. A capability being developed quietly, not in any official announcement, that, if it appears in Flight 13, will fundamentally change how we assess the entire crewed mission architecture of Starship. I'll get to that right now. If this analysis has been valuable to you, like, share, and subscribe to the Space Brief, so we can keep reading the data right together. Flight 13 isn't a step back, it's the only step that puts the Starship program on the right trajectory. Thanks for watching.